This video is for my pre-algebra classes. It is over lesson 69, direct variation. So a direct variation is a relationship formed when two variables are proportional. So, and now that's just a way of saying that as one variable changes by a factor, so factor, think multiplication. As one variable changes by a factor, the other variable changes by the same factor. So if we consider a table of values here, if this is my direct variation, and let's say that when I input 1, I output 3. This will mean that if I change my input over here to 2, then we have to consider what kind of a factor did we change this by. So, well, in order to get from a 1 to 2, we change that by a factor of 2. So therefore, what will happen over here is this will also change by a factor of 2, meaning that we will get an output of 6. Or let's say instead I go up to, let's say, 8 now. So from here I go to 8. So you could think of this as then, what does it take to go from an 8 to a 2? Well, you got to multiply it by 4. Or you could think of what does it take to go from a 1 to an 8? Well, you've got to multiply by 8. Either way you think about this, it's going to be the same thing over here. So then to go from a 6 to whatever this is going to pair up with, we also would have to multiply by 4. Or to go from the 3 straight down here, we'd have to likewise multiply by 8. So what you do to the one variable, you must do to the other. So this means over here, 6 times 4 would be 24. Likewise, if I were then to drop down, let's say, to 4, we look at this then and we realize, okay, constant factor, I could say I times this by 1/2, but because multiplication and division are related, we could say that we divide by 2 here. Well, if I divide by 2 to go from an 8 to a 4, then I will have to divide by 2 to go from 24 to whatever 4 matches up with. So therefore, 24 divided by 2, the 4 would match up with 12. So multiplication and division, whatever you do to one variable, you must do to the other. So now if, for example, I wanted to go down to, let's say, a 4 for my output, well, in order to do that, I would be dividing this by 3. That means that over here, to find this, I would also have to divide by 3. So what input would give me an output of 4? Well, 4 divided by 3 is 4/3, or 1 1/3. So that's how a direct variation works. We're going to go back to our paper now. So back on the paper, because these change by the same factor, what we have is a constant factor. And so we symbolize that with the letter K. K for constant in German. So in order to find this constant, what we're going to do is we're going to take our y value and divide it by our x value. And that will yield our constant. So I'm going to take my orange now, because that is a formula that you should know. I'll put a little box around that. So this is called a few different things. We can call this the constant of proportionality. That's one name, the constant of proportionality. This also sometimes gets called the constant of variation, since it has to do with a direct variation. Constant of proportionality, since it's proportional. Constant of variation. It turns out that your constant of proportionality is also the slope of the graph. That'll be the slope if we graph this out. And then remember that slope is really, in the real world, our rate of change. And then it can also be called, as we said at the beginning, the constant factor. So all of these are really just names for the same thing. They're all names for the same thing. Now, since this is constant, if we take a y value and an x value that pair up together, it's going to equal k. So another way of looking at this is, if I get a specific y value, my first y value, y sub 1, and divide it by x sub 1, so this would come from some point, x sub 1, y sub 1 would be a point in my graph, then that should equal k. Since this is constant, if I take a second pair of values, y sub 2 and x sub 2, coming from a second point in the graph, these also should equal k. For that matter, we could take a third pair of points and a fourth pair of points and a fifth pair of points and any number of pair of points that we want to, and the y value divided by the x value should always equal k. And so we're just going to go ahead and throw an ellipsis in here to say this could go on and on forever. Now, the point in bringing this up is that what we've discovered here is a proportion. And this will be helpful later down the road, because if ever we find that we have a point that we know, and we have a second point where we know only one of these values, we can construct a proportion that we can solve for the missing value. And we'll do some of that in just a little bit. So, moving down here, we also are going to take a look at this formula here and do a little manipulating, do a little algebra here. So if this is the formula for my k, then I can take this and I can multiply both sides. So I'm going to have to copy it down. So I can multiply both sides by x. Now remember that anytime that you multiply a fraction by its denominator, that the denominator and the whole number, okay, or in this case the variable and the variable, will cancel each other out. So this will leave me with just y, and on the other side we see kx. And what we've just discovered here is the form of the equation for a direct variation. So all direct variations will have equations that look like this. And we'll go ahead and label that this is the equation. So if you need to find the constant, you'll use this formula. So you'll figure out what your k is, but then if you want to write the equation, you'll take whatever this number came out as and put it in here. So for example, if we take a look at our table of values here, probably the easiest thing here would be throw in 1 and 3. So if my y value is 3 and my x value is 1, well, 3 over 1 is 3. So the equation of my dry erase board direct variation would be y equals 3x. Another way that we can identify a direct variation is by looking at its graph. So because its formula is y equals kx, where k is the slope, so if we think about our slope-intercept form, y equals mx plus b, well, we don't have a plus b, which means that all of these are going to go through the origin. They're going to have a y-intercept of 0. And then k will be my slope. So if I consider a graph here, I'm going to put that just right here. This actually will be a sketch of a graph. On a sketch, we don't always write out everything. We just get the general idea. So if I just sketch this out real quick, so if that's my coordinate plane, this line right here that goes through the origin could be a direct variation. For that matter, this line that goes through the origin right there could be a direct variation. And then it's not as common, but every once in a while, we do get a direct variation that has a negative constant. So what do we discover then about direct variations? Well, first of all, one, they are linear with a slope of k. They are linear with a slope of k. And then two, they go through 0, 0, or the origin. So take your red pen here real quick, underline linear and underline 0, 0. Those are the two things we're looking for when it comes to the graph of a direct variation. And then I'm going to just highlight this a little bit, make that stand out. Linear and through the origin. So we're going to take a few moments here now, and we are going to identify some direct variations. So we'll label this section checking for direct variation. So let's say we have the equation y over x equals 2. So first we're going to identify based on its equation. So based on its equation, is this a direct variation? So we want to get it into this form here. So what we're going to do is notice that we have y equals. We want to solve for y. So that means I need to get rid of this x. So in order to get rid of that x that we are dividing by, we're going to have to multiply both sides by x. And so therefore y equals 2x. So does this fit the formula y equals kx? Yes, it does. Not only that, but we can see here that k must be 2. Next, let's consider the equation y equals x over 2. So this, remember, fractions mean division, so this is really x divided by 2. Well, ladies and gentlemen, dividing by 2 is really the same as multiplying by its reciprocal. Dividing by anything is the same as multiplying by its reciprocal. So x divided by 2 is the same as x times 1/2, or 1/2 x. And here's a little secret that will help us out in algebra, that whenever you see a fraction with a variable on top, that variable can actually just slide off the top of the fraction. Now what takes the empty space would be a 1. So x over 2 really is 1/2 x. Just to practice this very, very quickly, this means that if I have x over 7, this is really 1/7 times x, or 1/7 x. If I have 2x over 5, the x can slide off, leaving a 2/5 behind, so 2/5 x. So back to it. Does this fit the formula of y equals kx? Yes, it does. Y equals, this is my k, x. So yes, this is a direct variation where k is 1/2. All right, in our next one, we're going to take a look at y equals 2 over x. Y equals 2 over x. Now for this one, we can slide the 2 off here. If we slide the 2 off to the side, this will leave me with 1 over x. And remember, ladies and gentlemen, that negative exponents make reciprocals, so I could rewrite this as 2 times x to the negative first power. So does this fit the equation of y equals kx? Well, ladies and gentlemen, consider what would be the exponent on this x here. Hopefully you just said positive 1. Is that the same as negative 1? Obviously it is not. So is this a direct variation? No. Because that negative exponent, no, we need a positive 1 exponent to be a direct variation. All right, continuing on, let's say we have a point, 3, 18, and we have a second point, negative 2, negative 6, and I want to know the line that goes through these two, does it produce a direct variation? So this goes back to up here. We have 2 points. So we're going to make a proportion. If these are proportional, then we're all set. So my proportion here is going to be the y values over the x values. So I'm going to have my y value 18 over my x value 3, which should equal my y value negative 6 over my x value negative 2. Remember, ladies and gentlemen, that if proportions are true, if these two fractions are actually equal, then their cross products should also be equal. Okay. Or, for that matter, honestly, this one's just easy enough. Why don't we just simplify them? 18 over 3 is 6, and a negative 6 over a negative 2 is 3. So, is this true? Obviously not. So this is not a direct variation. Next example, 6, 15 with a negative 4, negative 10. So in this case, again, set it up, my y value over my x value, my y value over my x value. This one might not be so easy, so let's go with the cross products this time. So if I take a look at my cross products, a negative 4 times a 15, well, 4 times 15, think about your clock, that's 60, but I got a negative. So negative 60 would be my cross product, and remember that comes from my 15 times my negative 4, and then that should equal this cross product. So 6 times negative 10, 6 times negative 10, which is negative 60. So is this a direct variation? Yes, it is. Now this method doesn't tell me what k is, but I could then go and just simplify either one of these fractions to figure out what k would be. All right, let's go back to this one. We said this one was not a direct variation. I would like to know here real quick, and I'm going to kind of slide this one over here so I can get a little more space. 3, 18, and let's say negative 2, what? What would we need this to be? If a negative 6 does not produce a direct variation, what would produce a direct variation here? So again, I'm going to set up my proportion. 18 is the y value over the x value 3. And over here, I used y for my y value. Let's try to be consistent there. If we're talking about a y value, let's put y as the variable. If we're talking about an x value, let's put x as the variable. So in this case, my y value we don't know, but my x value is negative 2. So to do this, we'd go ahead and do our cross product. So I'm going to have my 3y, and then 18 times a negative 2, 18 times 2 is 36, but it'll be a negative. Now, divide both sides by 3. Therefore, y must equal a negative 12. So if this was a negative 2 comma negative 12, then it would have been a direct variation. And now let's go ahead and flip our papers over. And on the back here, we're going to take a look at some table of values. Now our first one, y equals 4x, will be my equation. Now you should be able to tell from this equation, is this direct variation? Yes, it is. However, we're going to look at a table of values. That's the skill that we want to go over right now. And so I'm going to plug in a little bit on the left, a little bit on the right of the y-axis. So I'm going to start with negative 2, and work my way up to positive 2. So 4 times a negative 2 is a negative 8. 4 times a negative 1 is a negative 4. 4 times 0 is 0. 4 times 1 is 4. And finally, 4 times 2 is 8. So to see if this is a direct variation using the table, what we do is we add on a third column here to our function table. And this is going to be the k column. But remember that k equals y over x. So the y value divided by the x value. So what is a negative 8 divided by a negative 2? 4. What is a negative 4 divided by a negative 1? 4. What is a 0 divided by a 0? You better not have said 4. No, actually, I hope you said undefined. Can't divide by 0. That's actually okay. Anything that's undefined, we're just going to skip over. As long as everything else is the same, we're okay. So 4 divided by 1 is a 4, and finally 8 divided by 2 is 4. So is this a direct variation? Yes, it is. We can tell by the equation y equals kx. We can also tell by this third column. Anything that's not undefined comes out with the same constant. So k here, by the way, we can tell is 4. So how about the equation y equals x? Now this equation actually should be incredibly easy, but over the years I've noticed that a few students seem to really struggle with this equation. But it really should not be hard, because in order to find out what y is, it's going to equal x. So if x is negative 2, then y equals negative 2. If x is negative 1, then y equals negative 1. If x equals 0, then y equals 0. If x equals 1, then y equals 1. And of course, that's 2. So y equals x actually should be one of the easiest equations to work with. And so if I add on my extra column, my k column, negative 2 divided by negative 2 is 1. Negative 1 divided by negative 1 is 1. 0 divided by 0 is undefined. 1 divided by 1 is 1. 2 divided by 2 is 1. So is this a direct variation? Yes, it is. And the constant value is 1. Because remember, what's the hidden number that would be in front of this x? It would be a 1x. So yes, that is a direct variation. Next up, we're going to take a look at a equals s squared. So when it comes to setting up my table here, remember, ladies and gentlemen, that it's this first variable, just like y, that is usually our output. So that means that a is what I'm going to get out. S, this is the thing that I'm doing. Okay, I'm squaring something. What are we squaring? I'm going to put a number in for s and square it. So s is my input. Now this formula should look familiar to you. This actually is the area of a square. That's where the nickname for squaring something comes from, the area of a square. So because of that, I'm not going to choose negative values, and I'm not going to choose 0, because you can't have a square with negative side lengths, or for that matter, 0 for a side length. So we're just going to go 1, 2, 3, 4, 5. Remember that squaring means we're going to multiply it by itself. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Put in our third column. Here we go. Y values divided by x values. Actually, in this case, we don't have a y value, we don't have an x value. But what's taking the place of y value would be a. What's taking the place of the x value would be s. So a divided by s, area divided by side. So here we go. 1 divided by 1 is 1. 4 divided by 2 is 2. 9 divided by 3 is 3. 16 divided by 4, 4. 25 divided by 5, 5. Is this a direct variation? Do we have a constant of proportionality, a constant of variation? No. And hopefully we can see that from the equation up here. This should be y equals kx, or my output equals the constant times the input. Not the input squared, just the input. So no, this is not a direct variation. All right, and one more, and we'll be done for this lesson. Y equals a negative 2x plus 4. So we're going to go ahead and make our table here. Again, I'm going to go back to my negative 2 up to my positive 2. So pause that if you need to. And we're going to get going now. So a negative 2 times a negative 2. So 2 times 2 is 4. Negative times negatives cancel. So that's a positive 4. Plus 4 is 8. Negative 2 times negative 1. So negative 2 times a negative 1. The two negatives will cancel. 2 times 1 is 2. Plus 4 is 6. Anything times 0 is 0. So negative 2 times 0 is 0. Plus 4 is 4. And then a negative 2 times 1. Well, anything times 1 is itself. So a negative 2 times 1 would be a negative 2. So that'd be like going 2 steps to the left. And then if we come back 4 steps to the right, we'll be 2 steps on the right. So positive 2. And then finally, negative 2 times positive 2. 2 times 2 is 4, but the negative will tag along, making this a negative 4. So a negative 4 would be like 4 steps to the left. Plus 4 would be like going back 4 steps. Well, if you go 4 left and 4 right, you're right back where you began at 0. Make our column here. So, k equals, not y equals. K equals y over x. So 8 divided by a negative 2. 8 divided by 2 is 4, but the negative will tag along to make that a negative. 6 divided by a negative 1. 6 divided by 1 is 6, but the negative tags along to make it negative. Now technically we could stop here. Right now we can see that this is not going to be constant. So we already know, is this a direct variation? No. For good measure though, I'm going to go ahead and finish off my table. So 4 divided by 0, we cannot divide by 0. This is undefined. Cannot divide by 0. 2 divided by 1 is nice and easy. That's 2. And then here's the one that messes up students from time to time, 0 divided by 2. So if you have $0, and then that gets cut in half, well, it's half of 0. What's half of nothing? Well, nothing. Still 0. So looking at it this way, we can see, no, it's not a direct variation. And that, ladies and gentlemen, concludes our lesson.